Okay, hello everybody, and welcome to Carl and Camry revision sessions. The session this evening will focus on GCSE Mathematics and will be presented by Mrs. Claire Dixon from Penrose Harvest School in Swansea. The session will last around 45 minutes, where Mrs. Dixon will run through the relevant content. If you have any questions during the session, please use the question and answer section, and we'll do our best to answer you. Before the end of the session, you'll see there's a hyperlink in the question and answer section. If you're happy to leave your name and email address, we'd love to keep in touch with you so we can send you information about future events. You can click on the link at any time during the session. Today's session will be recorded, and the recording and any relevant resources will be uploaded to the e-sgol website under the Carl and Camry tab. Thank you, Mrs. Dixon. Over to you.
Thank you, Mr. Casey. Hi, and we are going to look at probability today. This is a topic that is very relevant to our maths GCSE, and we're going to specifically look at tree diagrams. Okay, and then next week we're going to go on to some conditional probability, which will involve some tree diagrams, but some worded questions then as well. So these are the things that we are going to look at today. Okay, so we're going to do a very quick recap of just working with fractions and decimal numbers. Those are really key to our probability work. And then we're going to look at a basic introduction to probability and then going on to our tree diagrams and our GCSE questions. So to start with, we're going to work with fractions. Now, multiplying fractions is heavily involved with our probability work. Okay, so this is a skill that is needed within this topic. So to multiply fractions together, we can multiply the numerators together and then multiply the denominators together. Now, what is kind of a downfall for some is that you will look at them and think, I've been told I've got to have the denominators the same. Now that is true for adding and subtracting fractions. For multiplying fractions, the denominators do not need to be the same. You are simply multiplying the numerators and then the denominators. So we're going to do a quick question. So I've got fractions 2/3 multiplied by 4/5. So you are simply going to work out 2 times 4, which is 8. And that will become your numerator, and 3 times 5 is 15. Now, for our questions that we need to do within our probability, we don't need to involve our simplifying, okay? We can leave our fractions like that. Of course, simplifying will be useful at some points, and maybe we will need to, but generally, we can leave our fractions as they are. Okay, so if you try the question over on the right-hand side, that's just appeared there. 7/8 multiplied by 3/11. If you pause the video and then I'll come back in a second. Okay, so 7 multiplied by 3 is 21, 8 multiplied by 11, 88, and you've got your answer. Okay, so moving straight on, and we're going to look at adding fractions. So again, this is what I've already mentioned. You do need to have the denominators the same when you add or subtracting fractions, but we are only going to look at adding today. And then we're going to use that fact then to obviously solve what we've got here. Okay, so we've got our quarter, 1/4, add 3/7. And we cannot simply just add the numerators and the denominators here. So we're going to convert these to equivalent fractions where our denominators are now going to be the same. Okay, so one of the ways to do it is to look at the 4 and the 8, go up in those times tables, find the lowest common multiple, and then you can use that. There are other ways you can do it. You can multiply them together and that will give you a value. Okay, so you can decide if you've been taught a certain way, obviously you can stick to that method. So going up in the 4 times table, going up in the 7 times table, they both go into 28. So we're going to change these fractions to find equivalent fractions where our denominators are 28. So if I now go back and look at the first fraction I had 1/4. To turn that into 4 into a 28, that needed to be multiplied by 7. Now, whatever you do to the numerator or the denominator has to be the same. So because we've multiplied the denominators by 7, that happens to the numerators as well. So 1 multiplied by 7 is 7. And then the right-hand side, then there's 3/7. To get that into a 28, we're multiplying by 4. And we do that to the and we have our equivalent fractions, but we have now fractions with the same denominators. So at this stage, all you have to do now is to add the numerators together. The denominator will stay as 28. So 7 add 12 is 19. So the answer to this question is 19/28. So please, can you pause the video and try the question on the right? Okay, so coming back in with this one, we have to, again, get these denominators the same. We've got 13 and 5 as our denominators. So they actually both go into 65. So we're going to rewrite these fractions as equivalent ones with 65 as the denominators. The first fraction should have been multiplied by 5, which meant then the numerator is now 30. And the fraction on the right-hand side, the 2/5 multiplied by 13, turning that numerator into 26. And you're now going to add your fractions where you only add the numerators. So it's 56 out of 65 as your answer. So if you can check your work, 56 out of 65 is what we were looking for. Okay, so moving on from fractions, we also need to be able to multiply decimals within this topic. So we're going to have a quick look at that, and then we'll be on to our probability work. So to multiply decimal numbers together, we use multiplying and dividing by 10, 100, 1,000, etc. So the first question I've got here is 0.3 multiplied by 0.2. So we're actually going to imagine that these are not decimal numbers, and we're going to multiply them, first one by 10, because we've got one digit after our decimal place, and the second one also by 10 again, because there's one digit after the decimal point there. So that would turn the question into 3 multiplied by 2, which you can work out to be 6. Now we have to reverse the process that we did in order to avoid those decimal values there. Okay, so we're now going to divide by 10 and divide by another 10 to reverse the 2 steps that I did at the top. So this 6 is going to be divided by 10 and then a 10, which obviously is the same as dividing by 100, which will bring you back then to 0.06. Okay, don't fall into the trap of seeing the 3 times 2, thinking obviously 6 is after the decimal point, so the answer is 0.6. Think about the process of getting them to be a whole number first and then reversing our process. Okay, again, can you try the question on the right, please? 0.15 multiplied by 0.6. So 0.15, if we multiply that one by 100, because we've got these 2 digits after our decimal point, that's going to give us 15. And 0.6, if we multiply by 10 to get that one to be a whole number, we will have 6. So 15 multiplied by 6 is 90. But we now need to reverse our processes. So we're going to divide this by 100. And then once we've got that, we're going to divide it by 10. So we could just divide by 1,000 in one step if you wanted to. So dividing 90 by 1,000, or in 2 stages of 100 and then the 10, you will then end up with 0.09. You could put the 0 after the 9 on the right-hand side if you wanted to, but it's not needed. You'll get obviously full marks for 0.09 there. Okay, so that's our quick recap of what we need to do in order to use our probability. Okay, so we are going to start looking at the probability from now on. So our introduction, okay, if you haven't come across probability, this is the basics that you need to know. So probability is the likelihood or chance of something happening. You might use words such as certain, likely, even chance, unlikely, or impossible, but they are words to describe probability. Now in higher tier, we wouldn't be using our words. Okay, we would be using fractions, decimals, percentages, knowing then the fact that's obviously written on the screen there, that all probabilities lie between 0 and 1. In order to actually write a probability as a fraction, this is what we would be looking at. Okay, so whatever probability it is that you're trying to find, the number of ways the event can occur, and then we're going to divide that by the total number of possible outcomes, and that would create a fraction that we can then use. Now, there are some keywords that you are going to hear throughout the lesson today, and obviously as you go through your probability topics or any revision that you do, and these are some of the keywords that you need. Okay, so probability keywords, we have outcome, right? So that is a possible result of an experiment or trial. So for example, if I flipped a coin, then an outcome of flipping a coin would be either a head or a tail. An event, okay, that is where you bring a set of outcomes together of an experiment. And again, if we go back to the coin, The flipping the coin would be the event because the outcomes that I could get from that would be a head or a tail there. Fair is also a word we would use. Every outcome is equally likely. So again, if we stick to the coin, it's not a weighted coin, it's just a usual coin where it's an equal chance of landing on either a head or a tail. And then the opposite of that is biased. So the tendency of an outcome is more likely or more or less likely to occur. So if you do get a weighted coin, sometimes you get them in kind of little joke things, and you will go and use them with your friends, and you'll say, right, I'm always going to pick tails, and every time, or more or less every time you do them, it'll land on tails. Okay, that's a weighted coin. That would create a biased result. Then you get keywords such as independent. Now that is where one event does not affect the other. So if you are flipping this coin and you flip it, you get a head or a tail on the first time, the next time you flip it, what's happened before doesn't affect what happens again. Okay, so the next coin flip is independent of what's happened before. The opposite of that is dependent. So one event does affect the other. Now that would be something like if you've got sweets in a bag and you want to take out, you eat a sweet, then the chance of you getting a certain sweet the next time would be affected because you've already eaten one sweet and it's reduced the number of sweets in that bag. Okay, so dependent would be affected by what's happened before. And then the last one I want to go through is mutually exclusive, and that is where events can't happen at the same time. So if we go back to the coin example, if you flip a coin, on one throw of that coin, you cannot get a head and a tail off the one flip of the coin. Okay, it's one or the other. So they cannot happen at the same time, so they would be mutually exclusive. Right then, and now we go on to a question. So this is starting off quite basic, okay, and we're going to then build up to our exam questions as we go through the lesson. So Jenna has a bag with 10 coloured balls inside, 3 green, 2 red, 4 blue and 1 yellow. What is the probability that she will pick out? And then we've got some questions here. Okay, so a blue ball. So all you have to do is count up how many blue you have and then put that over obviously how many you've got in total. Now you could count the balls that you can see on the screen, or you could go back up to the question and it does actually tell you there's 10 in there anyway. So 4 over 10 would be the answer to that one. Now, this question does not say anywhere about simplifying, so you would get full marks if you left your answer as 4 over 10. But of course, you could simplify that if you wanted to, and that would go to 2 over 5. Probability of getting a yellow ball, there's only one of them, so 1 out of 10. Red or green, now because of the word or, obviously we're counting up both colours there. So there's 2 red, there's 3 green, so we have 5 out of the 10, which would simplify down to a half. Probability of getting a black ball. Now there are no blacks in there, so 0 out of 10, but we wouldn't actually write it like that. Okay, 0 out of 10 is not the correct format. We could simply write 0. So probability of getting a black ball from this diagram that's shown is 0. Probability that a ball is chosen that is not red. Well, there are 2 reds, so that means not red is everything else. Doesn't matter what colours they are, as long as it's not red. So there are 8 of them out of the 10. And then 2 more here, so a green or a blue. So counting up your blues and your greens, and then you've got 7 out of 10 there. And then the last one is linked to this one. Okay, so a ball that is not green or blue. So that is everything else than what we've just worked out. Of course, you could count them, but you could also use the fraction that you've just had in part F, and this is how we'll go now and through the lesson, okay? And you could actually subtract. You could do 1, which is our total of all our probabilities, take away our fraction that we've just had, leaving you then with remembering that 1 can be written as 10 over 10. And it would leave you with 3 over 10 altogether. Okay, but of course, for this question, which is quite a basic one, you could just count them up anyway. Okay, so that is our introduction. Oh, sorry, I've lost my screen. There we are. Okay, so that's our introduction done. Okay, we're going to look now at the aim of the lesson, which is our tree diagrams. Now, you can draw a probability tree diagram to help you see possible outcomes, okay, of combined events and their probabilities. Now, these will work whether you have independent events or not, and so that means it makes them really useful for our GCSE that you will be sitting soon. So the tree, which is not actually a drawing of a tree. Okay, it's the lines that we use. It's a very basic structure. It actually tells us then the probability of every event happening along what the lines are going to be called the branches. And as you move along each branch, you'll combine the events then, and you're going to multiply the probabilities to get the overall probability of the combined event. Okay, so the first question we're going to look at is this one. So Sophie and Charlie have a snack for their break each day. The probability that Sophie has a cereal bar is 0.7. The probability that Charlie has a cereal bar is 0.6. These events are independent. And so remember our keywords now, it means that they're not affecting each other. Okay, construct a tree diagram to show this information and then calculate the probability of neither Sophie nor Charlie choosing a cereal bar. Okay, so to start with, this is the very basic structure that you would see. Okay, now we're going to do a little bit of highlighting as we go through this as well. Okay, so these sections are going to represent the left-hand side for this question. I'm going to take as the first person in the writing here, which is Sophie. So I'm going to label that so I know that this first section is for Sophie, and then everything then going across to the right-hand side there is going to be for Charlie. Okay, now it looks like obviously Charlie's got more things going on, but that is because we can follow on from what Sophie's choosing there. Once you've got which section is for what, you then need to label these branches. Okay, so these lines are called branches and you need to label them. Now this question is talking about whether they choose a cereal bar or they don't. So I'm going to choose the top line as being cereal bar. So I'm just going to put CB. And then the bottom one is not having a cereal bar. Okay, so not CB. That's going to be exactly the same for Charlie choosing a cereal bar or not. And then again, the same thing then underneath. Okay, so we're starting now to get a structure for the question that we need. Okay, so we've got our Sophie or Charlie with cereal bars, not cereal bars. The other thing that you'll be expected to do is to actually put our probabilities on here. Now, if we go back and have a look at obviously the question and read this sort of second section here, the probability that Sophie has a cereal bar is 0.7. Okay, so that is going to now be labelled on this diagram. So I need Sophie, I need cereal bar, and I need 0.7 on that section. Now each section is going to add up to 1. Okay, remember our probabilities will always add up to 1. So even though we're not told in the question a specific number, we can now write a number on this not cereal bar for Sophie as well. So because 0.7 and something will add up to 1, that missing value there is 0.3. Okay, so that's Sophie's section done. So if we now go on to Charlie, so Charlie's probability of choosing a cereal bar is 0.6. So if I move to the right-hand side, Charlie and cereal bar 0.6, and that would work for the next section down as well. And remember that every section must add up to 1, so that would then be 0.4 on both of the other branches. Okay, that in an exam would get you 2 marks. You've completed the tree diagram and you've labelled it with everything that you need to. Okay, so you've got 2 marks so far. So now we need to go on to part B, and it says calculate the probability of neither Sophie nor Charlie choosing a cereal bar. Sorry, it's the wrong thing there. Highlighter I need. Okay, so that means that Sophie and Charlie do not choose them. So this is like traveling and following a path that we need. So if I'm on Sophie's section, she has not chosen a cereal bar. So that would be following this branch here. Now from that branch, I cannot jump up to the top. It has to now continue on a path. So from that path that I've started, I now have 2 choices. I either go up slightly to saying that Charlie's having a cereal bar or down to say that he's not. Now the question says that neither Sophie nor Charlie have a cereal bar. So that would mean that I'm going to follow the path that says not cereal bar. Okay, so the highlighted section now is the path that I'm going to follow. Now, when you follow these paths from left to right on a tree diagram, you multiply, and every single time it will be a multiplication that you do here. So this question, the probability for not cereal bar for Sophie is 0.3. There's my 3, doesn't want to come up, there we are. And we're multiplying that by 0.4 because that is the path for Charlie not having a cereal bar as well. Now, if you think back to what we just did with our multiplying decimals, this is going to be the same as working out 3 times 4, which is 12, but then we're reversing our process of timesing by 10 and timesing by 10. So this would then need to be divided by 100 to bring it back to the question that was actually asked. So 0.12, don't read it as 0.12, that would be wrong. It's not tens and units, it's 0.12. Okay, so that question is now completed, and that second part would also be 2 marks. Okay, so we're now going to carry on with this start, and we're going to sort of link this now into our GCSE questions. Okay, so the first question is a non-calculator question. So this would be in a Unit 1 paper. And then again, we've got 2 parts of this question. You can see on the right-hand side, these are worth 2 marks each. And we've got a basic tree diagram drawn for us, but there are a lot of missing gaps in information from this. So we now need to pick out information from the words that are at the top. So let's have a read. So a box and a bag contain coloured balls, identical except for their colour. When a ball is chosen at random from the box, okay, so the box is the first section. I know I lost my highlighter then. Let me get my highlighter back. So the box there, okay, is the first section. So this left-hand side, the probability that the ball is blue is 3/5. So before I carry on reading, I'm now going to put that information onto the diagram. So the left-hand side is the box. The ball is blue is 3/5, 3/5. So that means the not being blue has to add up to 1. So if 3 out of 5 are blue, 2 out of 5 are not blue. So that would go on the bottom section there. Okay, so now I'm going to carry on reading the information at the top. So when a ball is drawn at random from the bag, okay, so we're now onto the right-hand side of this tree diagram. Okay, so the bag, the ball is blue is 2/9. Now, so that information can go on. Now, you should notice at this stage that one bit of information on the right-hand side has already been filled in for you. That is just to make sure that you know that it is the same thing going on the top section as it is on the bottom. Same as the left-hand side, these sections need to add up to 1. So 2 out of 9 are blue, leaving you with 7 out of 9 not being blue. Okay, so all of the tree diagram is now complete. That is worth 2 marks so far. So part A is done. Part B says calculate the probability that neither of the balls drawn are blue. Okay, so again, I'm going to go back to my highlighter now, and I want these to not be blue. So from the left-hand side, you always start on the peak at the left there. Follow the path that says not blue. Just going to go down here. And then from that section, I've got a lovely little line drawn there for me. I don't know why that's come there. Follow that section and we're going down to not blue again. Okay, so neither of them are blue. And if you think back to the last question we did, you always multiply along these paths. So 2 out of 5, 2/5, 2/5, however you want to say it, is multiplied by 7 out of 9. Okay. Now go back right to the start of this lesson, multiplying fractions. You multiply the numerators together, you multiply the denominators. The denominators do not need to be the same as each other. So 2 multiplied by 7 is 14. 5 multiplied by 9, 45. Does not say anywhere that you need to simplify. So that is your answer for that section. Okay, there's another 2 marks being gained. So you've got 4 GCSE marks in that question. Okay, if you can now pause the video and have a go at the question, you can see on the board it does involve some decimals. Okay, but it's the same process. Have a go at that and I'll be back in a second to go over it. Okay, so we're going to start going over it. So Rowena sometimes wears a hat and sometimes wears gloves. The probability that she wears a hat on a given day is 0.6, and quite nicely they've given us that on the diagram as well. So which means that I can already say that does not wear a hat is going to be 0.4, so that they together will add up to 1. If I carry on reading at the top, the probability that she does not wear gloves on a given day is 0.2. And again, they've drawn that on the diagram for us, which means that wearing gloves is going to be 0.8. Wearing a hat and wearing gloves are independent. Okay, so that line tells us that the bottom section is going to be a repeat of the one above. So I can put 0.8 and 0.2 on those branches as well. So part A, complete the tree diagram, that's done. Part B, calculate the probability that on a given day, Rowena wears a hat but does not wear gloves. Okay, so let's have our highlighter back and let's actually go through where this is. So wears a hat. Okay, so from the first section, we're going to go up. We're going to follow the path that says wears a hat, and then does not wear gloves. Okay, is now following the path that's from there. Remember, you can't jump down to the bottom. Does not wear gloves is now going down on that section, but following our original path. So the values that you had on there was 0.6 for wears a hat and 0.2 for not wearing gloves. And you needed to multiply those together, which you should be a little bit more confident with your multiplying decimals now. 0.12 as your answer for that question, and that's your second mark there. Okay. Right, we're actually going to go back now to the question we started with, which was the question to do with Sophie and Charlie and the cereal bars. So that was the diagram you would have had, okay, and the one I drew up earlier. The one we did earlier was not having a cereal bar, not having a cereal bar. But part C now, or the next part there you can see says, calculate the probability of either Sophie or Charlie choosing a cereal bar, but not both. Okay, so this is another way that you could be tested on using your tree diagrams. It might not be that you only get one outcome from there. So Sophie or Charlie choosing a cereal bar, but not both. So let's start with the left-hand side. So if Sophie chose a cereal bar, she would follow the path that goes up here. But by her choosing a cereal bar, that would mean that Charlie would not, okay, because the question says not both. So from that path, we have to then follow the not cereal bar. Okay, so that's one option there. Now that would give me a probability of 0.7 multiplied by 0.4. I'm going to highlight that in the same colour so you can see exactly where that's come from. Okay. And I'm going to put it in a bracket just to tidy that up. Okay. The other option would be that if Sophie did not choose a cereal bar, that would follow the path that goes down here. But if she did not, then that would mean that Charlie did. So we would follow this path there. Okay, so separately now we would work out the probability of 0.3 multiplied by 0.6. The pen seems to be on a little bit of a delay here. Just wait for that to appear. Okay. And that is the green section. So just like we've done before, we are going to multiply these decimals. We're going to get our answer. But once we have our answers, we're actually then going to add our answers together. So 0.7 multiplied by 0.4 is going to give you 0.28. We're then going to add that to 0.3 times 0.6, which is 0.18. Okay, and adding those together will give us our overall answer of 0.46. Now remember, probabilities can't be bigger than 1, so you should be checking at this point that your answer does actually make sense and that you are still within the 0 to 1 section. Okay, so you could have a question that has more than one possible outcome. Okay, so if you can pause the video now and have a go with the next question for me, we'll go through this one in a second. Okay, so I'm coming back in then to go through it. So a factory has two machines, A and B, which it uses to make large numbers of certain item. Machine A is used to make 60%. Machine A is used to 60% of the factory's total output, and then machine B is used for the remainder. So let's get that information on the diagram first. So machine A is already labelled for us, so that I'm going to write it actually as a decimal because I prefer to work with decimals than our percentages. So 0.4, 6, which leaves 0.4 for part B. Then if we carry on reading, it said the probability of an item that is made on machine A being rejected is 0.1. Okay, so that means accepted must be 0.9, so that they would add up to 1. Now this time, the probabilities are not the same, but the question gives us these probabilities. So the probability that an item made on machine B is rejected is 0.2, leaving then accepted as 0.8. Okay, so you need to just check that your tree diagram is correct. And then we're going to have a look at part B at the bottom there. And it says, calculate the probability that an item chosen at random is accepted. Now, this does not say what machine it's being used for, but it is only talking about one item being accepted because it's saying an item. Okay, so if we use machine A, that would then lead us to being accepted as 0.9. Okay, so we've got 0.6 of choosing that machine, and then 0.9 for being accepted. So the starting calculation would be 0.6 multiplied by 0.9. And then if we then work out the probability of being accepted from machine B, so the chance of choosing machine B, first of all, is 0.4, and then being accepted on that machine then is 0.8. So you would be looking at following what I've labelled as the yellow path there. Now we will be adding this in a second, so we're going to already put my add sign in there, and we're multiplying that then by 0.8. Okay, so what you should have done, 0.6 multiplied by 0.9, 0.54. Adding that to 0.32, which has come from obviously multiplying the 0.4 times the 0.8. And then when you add those together, 0.86 is your answer there. Okay, so that's that question done. I'm going to move on now to this question here. This question is talking about not picking a certain balls. Okay, so we're going to look at a quicker method of doing this. So using the information first of all, a game involves 2 bags, each containing coloured balls. Okay, bag A has 1 red ball and 4 yellow balls. So you can see on the diagram they've labelled 1/5. That has come from 1 being red out of the 5 in total that you had in that bag there, which leaves you with 4/5 for our yellow. Bag B contains 2 red balls and 1 yellow ball. So that is 2 out of 3 in total, leaving you with 1 out of 3 for your yellow. And then that repeats then on the bottom section there. Okay, so that gets you your first 2. Now, calculating the probability the player does not pick 2 red balls. That could mean, okay, and I'm going to put some highlighting on here. That could mean that we could do a red and then a yellow. It could mean that we do a yellow and then a red, or it could mean that we do a yellow and a yellow. We want to do everything other than the red and the red. Now that involves working out 3 separate probabilities. That is going to be quite time consuming in an exam, and obviously we want to save a little bit of time. So instead of doing that, because you know the fact that all probabilities add up to 1, what we can actually do is the reverse of the question to start with. So by saying, let's choose 2 red. Okay, let's go with that process. So if we go red and then red, if we work out that probability, we can then subtract our answer away from 1, and it will give us the remainder without having to work out 3 different sections there. Okay, so probability, and I'm going to write it as P for probability and red, red. That is going to be 1/5 from choosing from bag A multiplied by 2/3 of choosing from bag B. So 1 times 2, 5 times 3 gives you that. Okay, 2/15. That's not our answer. That was the opposite of what we're looking for. Okay, so we are now looking for 1 take away 2/15 to get everything else, all the yellow highlighting that I've got here. Remember that 1 can be written as using the denominator from the other one as 15 over 15. So take away 2 over 15. Taking away your numerators, 15 take away 2 is 13 out of the 15 that you had altogether. Okay, so that answer there, 13 out of 15. So can you try the next one in a very similar way? Okay, looking at the quicker way of doing it and looking at kind of the reverse process. Now, a lot of information is on here, but you have got to remember you've got some decimals and fractions. There's actually a mix of formats going on here. So pause the video and have a go with that. Okay, so members of a club can either walk or get a bus to a fair. None of them visited the fair more than one day. A member of the club was selected at random and the probability of them walking was 0.35. So before I go any further, I'm going to fill in the bus. They need to add up to 1, so you should have 0.65 on that branch there. I'm going to go back up and carry on reading. So the probability of them going to the fair on the first day was 3 over 5, which means obviously that they're not on another day then is 2 out of 5. That would match at the bottom of the diagram as well. Okay, complete the tree diagram, we've done it. Calculate the probability that the member of a club was not one of those who travelled on the bus on the first day and then the first day of the fair. Okay, so let me just get my highlighter. So that would mean we're actually going to work out the probability of them going on the bus, because we're going to do the opposite. So we're going to do probability on the bus and the probability of them being on the first day. And then once we get this answer, we're going to subtract away from 1. Now, I don't want to work in different formats, so I'm going to change my 3/5 into a decimal in a second. So I'm going to do 1 take away 0.65 multiplied by, now 3/5 as a decimal, you should know, is 0.6, so that's going to go in there instead. Now 0.65 multiplied by 0.6 is 0.39. So 1 take away that is going to give us our answer. So you should have an answer here of 0.61. Okay, so if you can check your answer and just make sure you've got that. So we got one more style of question to have a go at. So still probability trees, but worded in a slightly different way. So let's have a read of this one. So the probability that Daisy wears a bracelet is 0.7. Quite nicely, that's on the diagram for us already. So I'm going to put 0.3 on the other branch to make that equal 1. I'm going to go back up now, and it says the probability that Daisy wears a bracelet and wears a necklace is 0.63. So that is not the probability that she wears a necklace. That is the probability that she's got a bracelet and a necklace on. So if we think back to what we've done throughout the lesson today, that would involve multiplying. So what we've actually worked out, or what we've given here, is that the answer from following the top 2 branches, because that is wearing a bracelet. Oh, I lost my highlighter, 1 second. That is the probability of wearing a bracelet and wearing a necklace. They would give you 0.63. So you've actually then got to do kind of a reverse thing going on here, and you can use the space that's given on the question. And I've lost my pen. Where's it gone? Where's my cursor gone? There we are. Oh, I mean yellow, that's why. Let me just go back to red. There you go. Okay, so 0.63 would need to be divided by 0.7 in order to give you what would go on the wears necklace section. So again, you can think of this as 63 divided by 7. You can put your decimals, then multiplying and dividing by 100 can be used again. So 63 divided by 7 is 9. So this is going to be 0.9. So it's actually, this is where a trap kind of is set up for you. Most people here would put 0.63 on that branch. It's not, you have to divide, it's 0.9. Now you know that, it can link you quite nicely into the other one, so 0.1, and then repeat then for the bottom section there. Okay, so find the probability that Daisy does not wear a bracelet and does not wear a necklace. So if we have a look at where that is on the diagram. Okay, so does not wear a bracelet, does not wear a necklace, is following the bottom 2 paths across. So it would be 0.3 multiplied by 0.1, giving you an answer of 0.03. Okay, so just one question for you to try there. So if you can pause the video and have a go at that for me, please. Okay, I'm going to go through this one now then. So you should have read that obviously the probability that riser is 0.7. So this is 0.3 here. And then this section, riser and stops for a break, is 0.42. So that would be the end of this section. So here you would need to do 0.42 divided by 0.7, giving you then 0.6 that would go on this top section. Okay, leading you into 0.4 here, and then repeated underneath there. Okay, so completing your diagram, if you notice this time is now 4 marks. That's because of this division that's going on and the extra steps involved. So the bottom part, part B, calculate the probability that Alwyn travels through Hereford but does not stop for a break. Okay, is following Hereford coming down that way, does not stop for a break, then keeps going across the bottom there. So at that stage you should be doing 0.3 multiplied by 0.4, answer 0.12. So if you check your work there and have a look at what you've done. Okay, so this is where we're at the moment. Okay, we've done what we needed to do. We're just going to finish off with one quick question. And if you pause the video, have a good read of the question, and then it's which answer is correct from what we've got given there. Okay. So every Saturday, Jason attempts the crossword puzzle in his newspaper. The probability that Jason finishes the crossword is 0.8. Okay, so if we think back to that question with Sophie and Charlie at the start, we labelled what was going on. Okay, so we're going to do that again. So Jason is going to be the first section, and that would produce the fact that if he finishes it, so I'm going to write finish on here or not finished, those are our options. And we are told that if he finishes it, it's 0.8 is his probability, which means that it's 0.2 then for not finishing. If you then carry on reading, it says if Jason did not finish the crossword, his sister Megan, so I'm now going to label my right-hand side as Megan, so if he didn't finish it, Megan then finishes the crossword and that probability is 0.6. Okay, so let's label it as finish and not finish again. But this time the probability is 0.6, which means obviously 0.4 down on that bottom section there. Now I haven't finished or completed anything at the top part, and that is because this is talking about a crossword being finished. If Jason has finished the crossword, there would be nothing for Megan to have a go at. So that tree diagram for the top part doesn't exist for Megan, okay, because the crossword has already been finished. So where the question says what is the probability that the crossword gets finished, doesn't matter who is doing it, okay. For Jason finishing it is 0.8. So that would be the first probability. And we would then need to add the probability of Megan finishing it. Now for Megan to finish it, it would mean that Jason did not finish it, so 0.2. And then multiply that by the probability of Megan finishing it, which is 0.6. So this was the calculation you needed to do here. So 0.8 add 0.12. That looks like a 7 is actually meant to be a point and a 1 and 2. And then when you add those together, you get 0.92. So the correct answer there, or got rid of it there, I'll just circle it, 0.92. Okay, so that is the end of today's session. Thank you very much.